Hey guys, I'm WeiXi, who is an OS expert for openEuler community. So today I want to give you a lightning talk about how AI and operating system is married together. So right now the openEuler is evolving and trying to unleash the AI power. As you can see, we have this AI for OS projects, which are named as AOPS and ATune. And both of the objects are trying to simplify and making the Linux operations and maintenance efficient and faster. So the AOS is trying to enable fast fault locating within several minutes, while Atune is trying to intelligently determine how the applications can be optimized. At the same time, we have this operating system techniques to power the AI infrastructure, which include a generalized memory management that tries to connect all of these nodes within a cluster to provide a petabyte scale memory management, as well as efficient computing from heterogeneous scheduling between all kinds of heterogeneous computing power. So the first thing I want to introduce is AOPS. AOPS is, as you can see from the diagram here, AOPS is collecting the log information from all of the nodes from the clusters and then sending those collections to a server node using statistical models, artificial intelligence, called solid inference, in order to give you a vision of where the fault is located and how the fault is generated so that you can determine the root cause of performance degradation or any other kinds of problems. With AOPS, we are able to diagnose the cluster for all kinds of problems like networks, hardware drives, processors, or any kind of this stuff within several minutes. And the system logging overhead is within 0.5%. We further introduced Atune, which is an AI-powered intelligent tuning engine. With Atune, the current issue is that all kinds of applications rely on the configurations of the operating system. For example, the network configuration is very complicated. There are so many parameters that you need to tune, even though an expert like me cannot really do it quickly. At the same time, applications like databases, they also have a huge amount of parameters, and that is very difficult to tune, especially when you guys are not an expert and you want this Atune project to help you. So Atune has basically two kinds of modes. The first mode is named one-shot tuning. That is basically determining how the parameters should be configured at one time. While it also has another mode named iterative tuning that will iteratively change the configurations during the running of your application. So we tried Atune on a Spark application and we found that Atune is able to achieve 10 times faster of the optimization period and achieves even better performance than expert tuning. Atune has been deployed in practice and achieved like 5 times better performance for a database scenario for a real product. So besides AOPS and Atune, we also want to show you this demo that openEuler is now featuring a copilot part using the large language model to optimize your performance. So in this case, the administrator is asking the copilot to optimize the Nginx application. And the copilot basically gives some suggestions about the configurations. And after applying these suggestions, we can see that the performance is improved by 3 times. But this project is still under development, and stay tuned for better results and future updates. So after our AI for OS techniques, I also want to introduce GMAM project, which is our OS for AI technique. The vision of GMAM is that we want to let all kinds of applications to reuse existing memory service from the Linux kernel, which have already been optimized and have been sophisticated for years. The current situation, as you can see, we have all of these AI frameworks or AI applications reinventing the malloc libraries and also all kinds of device drivers, for example, NVIDIA's GPU driver or the async NPU driver, re-implementing the MM, which is essentially providing the same functionality as Linux core MM. And as a result, all of these APIs are not compatible with Linux mmap, so that you cannot really have a better programmability with these accelerators. And here is the overview of Gmem, where we allow all of these drivers and applications to reuse Linux core MM. So we have done some prototype with openEuler, and you can see Gmem code in openEuler 23.09. Gmem has allowed these AI frameworks to reduce their malloc library by like 5K lines of code, achieving 3 times faster performance with the malloc speed. At the same time, these device drivers, for example, NVIDIA GPU, async GPU, they spend like tens of thousands lines of code that are also reduced with Gmem. So the best part of Gmem is that it allows everyone to train a very large language model. For example, we train a GPT model with 52 billion parameters on an NPU with only 32 gigabytes of memory. And this is all powered by the memory over subscription technique from Gmem, utilizing the CPU DDR. So here are all the projects that openEuler is now doing with AI for OS and OS for AI. So you can follow up our Twitter or join our YouTube channel for further updates. Thank you.